Now we're trying to add 1/2 and 1/3. Well, it's obvious that the pieces are not the same size, and the numbers are different too. So you can see that from the problem. So we're going to try to make the smaller piece if we can. If we take a size 1/3, could we make a cut in the half in order to make it a 1/3? I'm going to put it on top of it. Well, yeah, I can get 1/3 out of that, and there's some left over. But that piece isn't going to be another 1/3. That's going to hang over. Can you see that this piece, this other 1/3, is not the same size as what I have left? We cannot call these thirds. It's not, we have leftovers on this. So now we're certainly not going to be able to put the half over the 1/3. That's going to hang over too. So we're going to have to cut both of those, make cuts in the 1/3 and in the half in order to get a common denominator. Well, let's see if we can figure out our pieces here. Here's one, but that's going to leave too much. There's going to be some leftovers there. We know that 4 of these fit onto the half. We did that one in the other problem. Okay, that works out pretty well. And when we get to the 1/3, here I have an 1/8 there. And oh no, I have a skinnier piece here, so that's not going to be equivalent either. They both have to work before we can use it, so this is not going to be possible to use 1/8. What about our 1/6? Well, we could take 2 of these. That's good. And we could do 1, 2/6, and 3/6. Oh, that covers it up without any overlap. So our common denominator with halves and thirds is 1/6. But I have to make equivalent fractions for both the halves and the thirds in this case. The picture tells me that 1/2 is the same as 1, 2, 3/6. And I used 2/6 to cover up the 1/3. So I used 3 of the 6 to make the size of the half, and 2 of the 6 to make one of the thirds. Now we have a common denominator. The size of the pieces are all the same. So we simply can add the numerators. 3 plus 2 is 5, and keep the denominator, the label that shows the size of the piece. And that's how we would work this problem pictorially. But mathematically, how did we get 3, if we didn't see the picture, how did we get 1/2 to be 3/6? Well, if you multiply both the top number and the bottom number by 3 in this case, 3 times 1 is 3, 3 times 2 is 6. New problem. How did we get from 1, what did we multiply 1 times in order to get a 2? Well, we multiplied it by 2. 2 times 1 is 2, and 2 times 3 is 6. So we were making equivalent fractions on these through multiplication, and we could see that it's 3/6 and 2/6 because we used the manipulatives